Okay, just copy the question. We'll start in a couple of minutes. Okay, we'll solve another two to three problems today. Small one. Okay, guys. Shall we start the problem? Right. Let us now start with the given data. Okay. So what are the given data? So first he says the material of the belt is specified. That is how much? That is leather. Okay. Even the size of it is specified. So it is a flat belt which has 9 mm of thickness. What is the problem with this? Okay. 9 mm of thickness. And the width is being how much? 250 mm. Okay. So the cross section of the belt is being specified there. Very good. Is to drive a cast iron pulley. So material of pulley is specified. Material of pulley, that is nothing but cast iron there. Okay, and the diameter of which is 800 mm. So the diameter of cast iron pulley is the 800 mm. Okay. Next, what else? If active arc on the smaller pulley is 150 degrees Celsius, so theta S he has specified. Active arc on the smaller pulley is 150 degrees Celsius, and the stress in the tight side is 1.5 megapascal. So tight side Tight side in the sense it is 1. Okay. So slack side is taken as 2, isn't it? So tight side is 1. In that, sigma 1 he has specified as 1.5. Stress he has specified, which is 1.5 megapascal. Find the power. So what we have to find? To find power transmitted. Okay. How much power is being transmitted, that we have to find. Take the density of the leather. So density of the leather he has specified. I will take that. So rho of leather is how much? 1000 kg per meter cube. And friction between pulley and belt is as 0.25. So this much data he has given the problem and is asking us to calculate the value of power. Shall we start? Solution. Okay. Ready? Shall we start? Okay. Fine. So the first, always remember, the first step in the belt drive calculation, whether to identify, should I consider the value of TC or not? Should I consider the value of TC or not? So on what basis will you identify, should I consider the value of TC or not? On what basis, on which parameter do you decide? TC in the sense it is centrifugal tension. So on which particular parameter you decide that you want to consider the centrifugal tension or not. V, isn't it? So we first always calculate the value of V, velocity of the belt, because based on that only you can judge for the suitable formula of power. So velocity of the belt, so V is equals to, normally it was pi dn by 60, isn't it? Now, since suppose this is the okay, so this is the pulley upon which the belt will be placed like this, isn't it? So this has some thickness, as you can see here. Okay, this has some thickness also. Just a minute. Okay, so this is the formula when you consider the velocity to be directly diameter. So when you consider a pulley like this, what happens is when you take the diameter, so this is the diameter, right? This is the diameter of the pulley. So even you have to consider the thickness also, the thickness of the belt also, isn't it? D plus T. So both the things you have to consider. So remember, whenever you have the value of thickness being given, you have to even consider the value of thickness in calculating your velocity. So the formula would become pi capital D. So this is a new thing. I'll be just writing it in a red color. So in the N divided by 60, correct? So in the bracket you can write considering the given thickness. Considering the given thickness, you can write. Okay. So now substitute all the values in a proper units. So pi, substitute in meters over here. D is 800 mm. In meters it is 0.8 plus thickness is 9 mm. In meters divided by 1000. So 0.009. Check this value. For its correctness, it's into 100 divided by 60. Now, what the value of V will you get? Whatever value you get, it would be in meters per second. What is the value? Yes, 16.94 meters per second. Now, whether this value is greater than 10 meters per second or less than 10 meters per second, that you have to decide upon. Definitely, this particular value is greater than 10 meters per second. That is why you are supposed to calculate using centrifugal force. Now, just write the sentence here. Since V is greater than 10 meters per second, the effect of centrifugal tension, which is capital TC, okay, has to be considered. Effect of centrifugal tension has to be considered. So what difference does it make while calculating your power? In the sense, you might have to use another formula, which is given by P is equals to BTV whole divided by 1000 into sigma D minus W V square divided by 10 to the power of 6G into e to the power of mu theta minus 1 divided by e to the power of mu theta. So even we had a derivation for this while we are studying design. Okay. So this is the equation, and this particular equation is available in your data handbook also. Can you get the equation number, anyone? Please check if the equation is right or wrong simultaneously. Just check your data handbook and give me the number, equation number. It is there in your data handbook, that is for sure. (14.5a). So this is equation number 14.5a in the page number 291. So in this particular slot, you can find this particular equation. So every parameter is known except the value of W. So what is this? Is nothing but the weight density. This is given by rho into G. Density of the material bed is specified as 1000 into acceleration due to gravity is 9.81. So it is 9810 Newton per meter cube. This is nothing but weight density. You have already studied this in FM. Okay. Now substitute, please substitute the values here. So P is equal to, what is the value of B? It is 250. Cross thickness is 9. Cross 16.94 is the value of velocity divided by 1000 into sigma D value is 1.5 minus 9810 is W into 16.94 velocity square divided by 10 to the power of 6. 10 to the power of 6 into G. G value is 9.81. Okay. (9.81) into e to the power of MEV is given as 0.25 cross 2.617. What is this 2.617? Convert this into radians, by the way. 150 degrees is nothing but pi by 180. So 150 into pi by 180. This would turn around to 2.617 radians. Okay, that value I have substituted here. Minus of 1. This whole divided by e to the power of 0.25 cross 0.0. 2.617. So what is the value of this big equation substitution? (43.209 kilowatts). Just check the value. Is the value correct? Okay, 22.2. One more value. So which one is correct? 43 or 22? Vikit is also getting 22 goes. Okay, 22. So 22.21 kilowatts. Understood the problem? Any doubts in this particular problem? Any doubts? Any doubts? If you have, please let me know. Okay, so immediately jump on to the next problem and please do copy this. And after copying also, you can please try this. It is very much same. Okay. check the data handbook. It would be of 1 minute. Where is that formula? What we have took this particular thing, 291 14.5a. So substitute in mm. Okay, BTV. That is why you're dividing it by 1000. So you must be in a position to understand the formula from now on. Okay, so B and T is there, dividing it by 1000 to get in kilowatts, that is. So to get in kilowatts, you're dividing it by 1000. No issue, you can substitute in mm only. Okay, the textbook answer also is in 22. So whatever answer you have given, that is correct. Okay, so substitute in mm. And even if you want, you can just mark a sentence here in your data handbook using a pencil. Don't write a huge thing, just mark substitute in mm. So just to avoid confusion, okay, you can mark yourself in your data handbook. Please copy this problem. We will start in after 2 minutes. Okay. So this problem is again a similar thing, but a little bit. It's all our basic level problems. Okay. The flat belt is required to transmit a power of 25 kilowatts. So P is given here 25 kilowatts. Very good. Flow of a pulley is 1 meter effective diameter. So directly he has given DE, effective diameter, in the sense it covers even the thickness also. That is what he means. So DE is nothing but it is effective diameter. Effective diameter, which we can understand it to be D plus T. Okay, it's given cumulatively. At a speed of n is being given, n is 400 rpm. Okay, the angle of contact is spread over 11 by 24 of circumference. So simple. So you take a pulley. So upon this belt will be placed, isn't it? Okay, so belt will be placed like this. So whatever the angle of contact is there, so this is your angle of contact, isn't it? This is what? This is angle of contact. And what he says, this angle of contact is spread over 11 by 24 of circumference. So circumference in the sense total, starting from one point to the full point. How many degrees in a circle? How many degrees in a full circle? Circumference in the sense it is total. So what is the total degree, that maximum degree that you can get? 360, isn't it? So it would be 11 by 24 of 360. So what is the value? What is the value? 11 divided by 24 of 360. 165. So 165 is in degrees. I want in radians. So 165 degrees. So if I want to convert it as 165 into pi divided by 180. So give me the value in radians. Theta. 2.87 radians. 2.87 radians. Very good. Next, what else is given? If the thickness of the belt is 8 mm, so even he has mentioned the thickness 8 mm. Okay. And mu value is how much? Mu value is 0.25. Rho value is again 1000, density of the belt 1000 kg per meter cube. And working stress sigma 1 is nothing but how much? 3 megapascal. Determine the width of the belt he is asking. Oh, beautiful. So this is a belt, cross section of the belt. So he has given us the thickness value. How much is the thickness value? 8 mm. So now what is asked is the width of the belt is being asked. This you have to find out. Since he has given us the power, no problem. You can calculate it. Okay. So to find us this width of the belt. Now, shall we proceed? So what is our first basic step? Everyone, what is our first basic step in belts? What is our first basic step? What should we do first? What is our first step? To calculate V and check whether should we consider the value of TC or not. So for that, calculate the velocity of the belt. Okay. Now this is a very tricky problem. See, pi is equals to pi dn by 60. So now this here, he has directly given us the value of effective diameter. Okay. Should I add T again to this? Should I add DE plus T to this? Should I add DE plus T? No. Please be very careful. He has given us the effective diameter, which is a cumulative of thickness. Already it is a cumulative of thickness. So you shouldn't add it again the 8 mm. Okay. Enough. Give me what is the value? It is pi times of 1000, in the sense it is 1 mm into n value is 400 divided by 60. So what is the value of velocity in meters per second? .94. Okay. For this particular velocity, should we consider the centrifugal tension? Should we consider the centrifugal tension? Yes. So just write the sentence. Since V is greater than 10 meters per second, the effect of TC has to be considered. Okay. Once you write the sentence, pick the same formula again. P is equals to. So this is the formula. If you observe the data handbook, this is the formula you have to use when TC is considered. So this is the formula you have to use when TC is considered. When TC is not considered, you can use the other formula. Okay. So P is equals to BTV divided by 1000 not is equal to into sigma d minus WV square divided by 10 to the power of 6. 10 to the power of 6g into e to the power of mu theta minus 1 divided by e to the power of mu theta. What is the equation number? What is the equation number? 14.5A, 291. So 14.5A in the page 291. Now again, substitute each and everything carefully. The value of P in kilowatts is 25. B, that is the parameter which you are supposed to calculate. T is 8 mm. Velocity is 20.94 divided by 1000. And what is the value of sigma D is given? 3 minus W is, what is W by the way? What is W? It is rho into G. So it is 1000 into 9.81. So it is 9810 Newton per meter cube. Okay. Substitute the same value, 9810 cross V square. So V is again 20.94 its square divided by 10 to the power of 6 into 9.81. Okay, into e to the power of mu value is given as 0.25. Mu value 0.25, yeah, 0.25 cross theta value we have calculated to be 2 point something and 87, 2.87. Okay, minus of 1 divided by e to the power of 0.25 into 2.87. So just try to solve this. First divide 25 divided by this whole lot of number. Okay, then you can solve it easily. From this, what is the value of B you are going to get in mm? $113.78. 113.78 mm. Very good. Now, whenever you have a width, you need to standardize it. For that, all of you just refer, first of all, before I say the table name, please refer your data handbook and let me know, is there any table through which I can standardize, the value of B, that is width of the belt. Do I have any sort of table through which I can standardize the value of B? Please check and let me know. Refer your data handbook, all of you. Those who have the soft copy also, they can refer it. (14.9A) is that table number. What is the page number, Dhanush? (311). Yes, here it is. So nominal width of friction surface rubber transmission belting according to ISO 1370 to 1965. So here are the standard values of the belt. You can find it in the page number 311. So please standardize the value. Okay. So just write standardizing above value, above obtained value using table number 14.9A, which is at page number 311. So what is the standard value you are going to give me? $125. Okay, 113 in the sense you can go for 125. Okay, done. So 125 and done. So how many of you are agreeing with this? Can I go a lower value? 112? 112 is also available. 112 is available, right? So you have got 113. No. Okay. But your textbook, textbook JBK Das has taken 112 as a value. Okay, even he has got 113, he has taken 112 as a value. No issue. You can take 125 as a value. Absolutely, you guys are perfect. Okay, don't worry about it. Clear with the problem? Any doubts? Any doubts? If you have, let me know. Any doubts? Okay. And the last problem of the day. Okay, it's a huge problem. What to do? 2 problems you have solved right today. No issue, guys. So we will leave the class early. Okay. So you just take the screenshot of this particular problem. So copy it down. We will solve it in next class. So just take the screenshot of this particular problem. Okay. And copy down in your notes. After your internals, we will solve this particular problem. Okay. So all the best for your internals. Do well. So I told you the internals pattern in the last class. So mark your attendance in the Google Sheet. Then you can leave your class. Okay. Have a nice time ahead.
Sir, Radvik.
Sir Gagan.
Sir, Radvik.
Sir Sumit.